So welcome to Contemporary Math. Today we're going to start our final chapter on statistics. And statistics is the art and science of gathering, analyzing, and making inferences or predictions from numerical information called data obtained in an experiment. So there's really three main parts of statistics. We deal with gathering information, analyzing that information, and then using that information to make some predictions. So when we look at this, we need to obtain data to be able to do all this. So we actually have two branches of statistics: descriptive statistics, and this is collecting, organizing, and analyzing, and then inferential statistics now is making generalizations or predictions based on the data. So the specific data is numerical information obtained in an experiment. And so we look at the numbers that we get from certain things. The population here is all items in a group. And we relate this to when we were talking about set theory, and we relate this to the universal set. So a population is the set of all objects for a specific topic or subject. So we can think about the population of the United States of America. And if we're going to take a census, we want to figure out exactly what that entire population is, and it's all the items in the group. Now, in statistics, a lot of times looking at the entire population is not really viable because it would just take too long to gather all that data. And so what we do is we look at a sample, and this is some items of a group, and it's a subset of the population. And we use it, we zoom in on a small sample to study the entire population. So again, in thinking about our set theory here, we have a small sample of the entire population, and by looking at everything in this sample, we're trying to say, can we make generalizations about the entire population? So to be able to do this accurately, we need something called an unbiased sample. And this is a smaller replica of the entire population, and it accurately reflects all the attributes of the population. So basically what we try to do is make this sample look exactly like the population, only smaller. So the same percentages of types of people are represented, and everything is exactly the same, just smaller. Now let's move on. How can we obtain an unbiased sample? We want to look at different sampling techniques. So the first one is called random sampling. Now this is a system where each item is considered an option and has an equal chance of being selected. So the best method is to assign each item of a population a number and then use a random number generator to select items. Another way you can think about this is if we have a hat, you could basically assign everybody a number, and you put everybody's number in the hat, and then you would just draw out however many you needed to get your sample. So this way it does work, but a random number generator works the best, and I'll show you how to do that a little bit later in the lesson. Another type is called systematic sampling, and this is choosing every nth object from a population. And it's important that the first item should be random. So basically you take your whole population and you line them up in some way. So you put them in some sort of order. And then you just say, for instance, let's take every third person or third object in my population to be a part of my sample. And so we want to randomly start at a specific spot. Okay, so let's just say we start with this, and then every third object is going to get selected. So we go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so this would give me a sample of 5, and this would be systematically taken. Another type is a cluster sample, and this is often referred to as an area sample. So random samples of groups of units. So first we divide the population into sections, and then we randomly choose one or more sections. Now we can either take all the items from a section or a random sample from each section. So let me illustrate what I mean there. If we take our population, and we'll use this universal set idea, we can divide it up into some equal areas here. So let's just say we have our population and we divide our areas across the board like this. Then we can assign each area a number. Okay, so we have 10 sections. And let's just say we choose two numbers randomly. So we'll pick 3 and 9. So what this is telling me is that I want to pick everybody that falls in section 3 and section 9, and I'm going to choose all of them. Okay? Or we could choose to take a random sample out of these two sections, and that's cluster sample. Our next sample is a stratified sample. And here we divide the population into groups with similar characteristics. So it's kind of like cluster, but cluster is based on area, stratified is based on a characteristic. Then a random sample is selected from each group of characteristics. So we can separate people into age groups, we can separate them by how much money they make, we could separate them by education level, okay, ethnicity, or we could do something like eye color. So there's lots of different characteristics we can use to split people up. So let's just say we chose eye color as our characteristics. So we can have blue eyes, we can have brown eyes, we can have black, and green eyes. So what we would do then is every item in the population would fall somewhere in one of these categories. Now we could either take a specific number out of each group. Okay, this would give me a sample of 40, 10 blue eye, 10 brown eye, 10 black eye, and 10 green eyes. When you do it this way, sometimes you can have an overrepresented group or an underrepresented group. So if the percentages of people with blue, brown, black, and green eyes are not the same, like 25% across the way, and we split it up 10, 10, 10, then it may not be exactly an unbiased sample, because let's say there are more blue eyes than brown eyes, but they have equal representation in the sample. So it's kind of the difference between the Senate and the House of Representatives. Okay, in the Senate, each state gets 2. In the House, it's based on the percentage of your population. All right, our last sampling technique here is called convenience sampling. And this uses data that are readily obtained, and it can be biased. So this would just be like, pick the people around you. It's almost like the people who sit outside of the grocery store who ask your opinion of things. That's a convenience sample, just very easily to obtain. Now, let's go through some examples identifying what type these are. So in our first one, it says every 20th calculator coming off an assembly line is checked for defects. So because this is every nth item, this is going to be a systematic sampling. Okay, so it's every nth item. Now this could be problematic. Let's say there were 20 machines spitting out calculators at the same rate. Then if we checked every 20th calculator, it's possible that the same machine would get tested over and over and over again. So you still have to be careful with your systematic. The next one, a $50 gift certificate is given away. Tickets are placed in a bin and the tickets are mixed up. Then the winning ticket is selected by a blindfolded person. So this is going to be random sampling, because each person has the same chance of being selected.